start our today's session. So let me share my screen. Yeah. Hope you're able to see my screen.
Yes.
Yes.
Okay. So let's start our today's discussion. So yesterday we have discussed about the constraints concept, and we have seen the example of primary key constraint. So how to declare a primary key constraint on top of a column in the table, right? And the importance of data integrity in real-time projects, we have discussed that as well. And how actually this primary key is serving the data integrity part, right? So that is the key thing. Okay. Okay, so these are all things we have discussed yesterday. So we have discussed the introduction towards the foreign key constraint as well. So in the foreign key, we are trying to relate two tables by providing the reference from one table to another table, right? So that is the key functionality of the foreign key constraint. So foreign key constraint uh, always points to the parent key. Okay, so here if you see employees info table, in the employees info table, employee ID is the primary key, but we also have department ID. Okay, and this department ID is referring to the department's table department ID. Okay, so what does it actually this relation means, right? So let us try to let us try to experience the example so that we'll try to understand. Okay, so here I have created a departments table. Now I'm creating employees info table. Okay, so now if you see, I'm trying to insert a record. I'm trying to insert a record into the employees info table. Insert into employees info values, right? Employee ID 1, name Scott, department ID 10th department, right? That's it. So I just need to insert these records. See this, you won't be able to insert a record into your employees info table directly. Okay, so if you see, the conflict occurred the database retail table departments column. So it is saying the foreign key constraint conflict, right? So the reason is you cannot insert into the child key directly without inserting into your parent key. Be very, very clear. Okay. So what do I mean by that? Now just see the example. See here, I'm preparing one more insert statement into the departments table, into the departments table. Okay. And I'm saying department ID 10, and I will say the name of the department is HR. Okay. Now you inserted this 10th department ID into the departments. Then your employees info table will allow you to insert. Okay. So understand the concept, guys. Parent and child relation. You're establishing a relation between, the tables. Because you applied a reference to the parent table ID, it won't allow you to insert fresh records. Because it is a reference, it will take the reference from the parent table only. Without inserting the records into the parent table, you won't be able to access, or you won't be able to insert data into this table. I will tell you one simple example, guys. Okay. Without taking a bank account, will you be able to do a transaction in the bank? Is it possible? Respond, guys. Without taking a bank account, is it possible for you to do a transaction?
No.
No.
No, right? So it is simple, guys. As and when you create the account, your record will be inserted into the accounts table. Okay. And then your fact table, which is actually the transaction table, the account number in the transaction table will be referring to your accounts table. Okay. So that is where your tables are getting interacted in the real-time projects. You need to understand that. So you can simply think where we'll use all these things, but we are using it in the real world. You need to map. That's it. Okay. So the relation between the database table objects is very important concept in the real world. Okay. So what is the purpose of it? What is the purpose of this? What is the purpose of it? So you can simply just give me a minute. Yeah. So just let's try to understand a simple data model, guys. In the real time, how actually the tables in a database will be related, right? Will be related. If you see here, device info, right? It's a simple mobile devices based application. Okay. And for that application, the data model in the backend is this. This is called ER diagram. In the real-time projects, we call it as ER diagram. Okay. And we call it as a data model. Technically, it's a data model that sits in your database. Right? So simply people won't come and create tables and create web applications. No, it won't happen. Be very clear. There will be a design and there will be a model to your all tables that are required for your web application. Be very clear. That model they will design, and according to the model, your web application will get attributes. Okay. So why this thing needs to be done? This things needs to be done to normalize your data. This concept will call it as normalizing the data into the multiple different tables. Okay, if you put entire data in a single table, okay, your application may leads to dead state in sometimes because of the high volume of the data, right? So that is why in the back end, people will design a data model, and according to the data model, your web applications will act. Okay. And once web application starts pushing the data into the data model, in the back end your tables are connected. Okay, in the back end your tables are connected. If you see here, MD device info table is connected. MD model info table, the model ID is the primary key here, and the model ID is the foreign key here, right? And similarly, the other tables, right? How they connected, right? So you need to understand this kind of concepts. These are real time concepts. Okay. So this data modeling is a separate concept altogether. When we were in data warehousing with BigQuery, I will explain you that concepts, which are actually star schema, snowflake schema. So these are the data models that real time projects will follow, right? So when we were in BigQuery in Google Cloud, we will discuss all these things. Okay. But for now, try to understand where this relation between the tables is important and how actually it is impacting the real world, right? So it is as simple as your banking system. Okay. If you take your banking system as an example, you can easily relate. this tables relation. Okay. So going back, yes, now we understood if it is a primary key column, we won't be able to insert a duplicate record. We won't be able to insert a duplicate uh, value or a null value. So the primary key constraint will stop inserting duplicate or null values into that particular cell. Okay. And similarly, the foreign key can be utilized to establish a relation between the tables. Okay. And we call this foreign key as a child key. Okay. And this foreign key always refers to the parent key in the other table. Okay. So when it refers, if you try directly insert a new value into this referenced foreign key column, it will throw error, violation error. Okay. For that, you need to insert the record in the parent table. Then only it will allow you to insert the record in the child table. Okay. So that is the importance of your primary key and foreign key constraints. Okay. So now let's jump into the next constraints. So we have unique constraint, right? So let us see what is this unique constraint. So in the unique constraints, how you will declare unique constraint. Here, if you see user ID, username, email, so I declared user ID as a primary key constraint, and I declared username as unique constraint, and I email also unique constraint. Okay. So what is it actually means? Let us try to experience it with an example. So insert into users values of 1 comma Venkat comma Virai test at gmail.com. Okay. So this is my first record into the table. It will obviously allow. I created it. Okay. So I inserted my first record into the users table, and then I'm trying to insert the second record. I'm trying to insert the second record, same as the first record. Okay. Or else my primary key I will change. Okay. And I'm trying to insert the same values into the username and email ID. Okay. The violation of unique key constraint. So the unique key, the name itself is stating, right? It won't allow any kind of duplicate values. It won't allow any kind of duplicate values. You can ask me the question now. So what is the difference between primary key and unique key? Now let's understand that difference. Okay. So here, if you see, I'm trying to insert the data into the users table, and I'm keeping my name, username as null. Okay. So here, if you see, I have declared a unique key on top of my username, and I have declared primary key on top of the user ID. We know primary key doesn't allow duplicate values as well as null values. But if you see the case with the unique key, if you see the case with unique key, it will allow null values. It will allow null values. It has its own purpose, guys. It has its own purpose. In real time, few cases, few attributes, few attributes doesn't allow, they shouldn't allow duplicates, but they need, it may or may not be mandatory or optional sometimes, right? We may get some optional things in the web applications, we will see, right? So we may or may not enter. So in that case, it has to come as null, and then it should allow. But if we try to enter again and again, the same value, it won't allow. So something like that we should be experiencing in our web applications, right? It is similar to that. So here, if you see, your primary key doesn't allow duplicates as well as null values, but your unique key will only, allow unique values with null values. Okay, so that is the difference. Your unique key doesn't have null handling, but your primary key have null handling. You need to understand that difference. Okay, that is the unique key. Now let's proceed further with the not null key. Let's proceed further with the not null key. Yeah. Okay, so let me take this syntax. Okay, so here if you see, I'm creating a simple table called products not null. Okay, so the not null, the name itself is saying it won't allow null values. That's it. It won't allow null values. You have to give any of the value into it. Okay, it will allow duplicates, but the value should be present at any point in time. Okay, so let's try to insert the records. So I'm inserting the data into this products not null table, product ID, product name, let us say soap, and then price 20 rupees. Okay, I've inserted the data. Now let's see if I can insert the data into the product name as soap, and this one as 2, and price, I'm trying to go for null. So here if you see, null into the column price, column does not allow nulls. Guys, are you able to understand? Are you with me?
Yes, yes.
Yeah.
Any questions still here? Primary key, unique key, foreign key, and not null
No.
questions, queries? Okay. So let us understand the next constraint. So it will simply doesn't allow null values, guys. That's it. That's the uh, importance of your not null key. Though you allow duplicate values into the cells, it will take. Okay, so the next constraint is the check constraint. So let us understand that. So you can also insert the data into a table based on a condition. Okay, based on a condition. See here, I'm creating a check constraint on top of the age column. Okay, it will take the records only if the age greater than 8. Okay, so let us try to experience this check constraint. Okay, so now insert into employees check values employee ID 1, employee name Scott, employee age, let us say I'm trying to insert 14, salary 4,000. See this, you're violating the check constraint, right? So you need to understand this, guys. Okay, so if you are given a condition age greater than or equals to 18, then you must enter the data in that format only. 30,000, it should be 40,000, right? So your salary should be greater than 30,000 and your age should greater than 18. Then only you can enter a record into this table. That is the power of your check constraint. You can still stop the records based on a particular condition. Till now we have seen duplicates, nulls, right? But this is different. You are stopping the records coming to the table based on a particular condition. That is where your check constraint will work, right? Okay, so let's move on to the next uh, constraint called default constraint, right? So default is something, if you're not giving anything, it will take its own value. So that is what default constraint is. See here, in the orders underscore default table, I'm creating order date as a default. Okay, and let me put this to another column because it's hard to give date every time. Okay, so here I'm for the customer name column, I'm putting the default as get, sorry, default as, let us say, some x. Okay, for the status column also, I'm putting the default as pending. Okay, now let's try to create the table and let's try to insert the data into it. Insert into orders underscore default values of order ID 1, customer name, clock, order date. Let us say, I will say date or get date, I'll go with. And then status is completed, let's say. Okay, so here if you see, I'm trying to insert the data. So now I got my data, right? So now how actually your default constraint is working. So let's understand that. Insert into orders underscore default. I'm giving values here, order underscore ID, comma, customer underscore name. Okay, I have default here. I don't give it. Order underscore date. Okay, I will only give these two values. So I'll go for 2 and then I'll go for get date here. And I'm not giving the other two values, right? See this. So it will take, but it won't keep nulls. Usually, when we doesn't give any value in the insert statement, your database table will treat it as a null value. Okay. So, but whatever the default values that you have given, those default values have been taken. So that is the functionality of your default constraint. Okay, fine. We'll go with the last constraint, and then we'll close this constraints concept. Okay. So in real time, we may face a few situations in the table creations wherein the tables or you may get a situation wherein you need to create a primary key on two columns. Okay. So that primary key we'll call it as composite primary key. Okay. See here, I have a table called order items, and in that table, order ID and product ID I have, and I'm creating a primary key on top of two columns, order ID, product ID. Okay. Now, when you do this, what will happen? It will check the uniqueness based on the two columns. It will check the uniqueness based on the two columns. So what does it mean? So let's try to insert. Insert into order underscore items values. Order ID 1, product ID 10, and quantity 5. Okay, so this is my data. Done. Now I'm entering the same data into the table. It will throw an error because it's a duplicate. 1 and 10 both are duplicate. But if I change it to 20, though your 1 is duplicate, it will allow. So the reason is it will check the uniqueness in the combination factor. It won't check the uniqueness for single column. That is the functionality of your composite primary key. Okay, your composite primary key will check the uniqueness based on the two columns values. Okay, it won't take only one column as a reference to check the uniqueness. Okay, in real time, if you get a situation wherein if you want to apply the uniqueness on two columns, then we will use this kind of a primary key. Okay, so that is the importance of this composite primary key. Okay, so now we have covered almost all the constraints. Okay, so that's where we can close the constraints concept. Hope you got a good understanding on what constraint, what it will do, what is the functionality. We have seen the with examples as well. Okay, now the next concept that we are going to jump in is joins. Okay, so joins are very very important in SQL world, right? So if you can ask me what are all, what we can do with joins, the entire SQL is depends on joins only, right? So in a real time, if you see, just now we have seen a data model diagram, which is actually ER diagram, right? So that is something that you can understand from that, where actually we have multiple different tables in a data model, in a typical data model. and how you will extract data from multiple different tables. Till now, we know how to extract the data from a single database object table, right? We can apply a select and we can apply column names, and then we can apply a where clause, or group by, or min max, or we can add some new columns based on the case when statements. We can do whatever we want on a single table. Till now, that is what our understanding is. But in real time, you will be having a typical data model which consists of a lot of tables, right? So how we will extract data from different tables at a time. So that is where the joins comes into the picture. Okay. So what are all different join types that we have, right? So we have four major types of joins. Okay. And those joins are very, very important. Okay. So inner join, left join, right join, and full join. And we have one more join, which is actually cross join. Okay. So these are different types of joins we have. So what do I mean by join? The name itself is saying, right? So you can join two tables or two or more tables, and you can retrieve the data. That is the functionality of your joins. Okay. Now in the process of joining tables, depending on the join type, you will get the data. Be very, very clear. Okay. If you are using inner join, you will get the data in a different way. If you are using left join, you will get the data in a different way. If you are using right join, you will get the data in a different way. So you need to understand the functionalities of each and every join, and you need to know how to apply these joins on top of the tables, and where to apply what join is something that you need to understand. Okay. So now let us go step by step. So joins purpose is to extract the data between two or more tables. That is the core purpose of your join. Okay. And in the process of joining these tables, we have multiple different join types. We have inner join, and we have left join, and we have right join, and then we have full join and cross join. So these are the different types of joins. Okay, fine. Now let us understand what is actually a join and how it works, right? We will start with the inner join. Okay. So now I'm just creating a table. Create table, or else, okay, so I'll just create, because you need to understand the concept first. Okay. So create table underscore test. Okay. And then here I have id and sorry id int name varchar. Okay. And then I have another table, table underscore test to test one, or else I'll say test stg. And here I have id, and I have something like age. Okay. So now I'm creating one table, and that table will be having ID integer and name varchar. I created that table, and I have another table wherein table test stg, and I have ID int age integer. Now let me insert the records into this table. Insert into table underscore test 1 comma Scott
values.
sorry values. Okay, so similarly 2 comma Blake 3 comma Clark 4 comma James 5 comma Joseph. Okay, so now if I go and query my table test, so I have all my records, ID, name, right? So similarly, I need to insert the data into the next table also. Then we will try to see how we can extract the data between the two tables. So here if you see, I have ID1 and I have age 25. I have ID2, age 26.
Table name will be
Oh, sorry. I forgot to change the table name. It's okay, that will help us. But for now, I need to remove. Okay, so my table is clean now. Okay. Okay, so I'm just inserting into the stage table. So table stage, and then 226, and then 326, and then 426, and then 5. Okay. Okay, see, I have 5 records. Okay. So I have 1 2 3 4 5 in the first table. I have 1 2 3 4 5 in the second table. Now, how actually we can extract the data by using joins? Now let's see that. So here, if you see, I'm trying to apply a join function on top of these two tables. Okay, select star from table underscore test. Okay, as T1. This is table alias. We'll call it as, we have seen column alias, right? So similarly, you can apply table alias. Okay, inner join. Okay, inner join table underscore test underscore stage. Okay, so you can simply take provide table alias with space also T2. Okay, on. So the syntax for the join is, you need to specify which join it is. Okay, between the tables, and you need to specify a on condition t1 dot id equals to t2 dot id. Okay, so this is the syntax for a typical join. Okay, now if you do I need to specify inner join? Not mandatorily, you can specify join also, but by default your join function will utilize inner join internally. So that's why I have specified inner join. Okay, so what is inner join? Now let's understand this. Here, if you see, I'm executing this query. See, all my two tables data come into single table or single query output. See, you have two ID columns and name, age, right? Now you got entire data from both the tables. Now you are okay. Okay, so we joined these two tables on the ID column. We joined these two tables on the ID column so that we got all the data into a single output. Okay, but if you see the inner join, the functionality of inner join is, it will extract only the common records between the two tables. What do I mean by common records? For example, in your table 1, you have ID 1. In your table 2, you have ID 1. So that is why it is a match. It will return the record. In your table 1, you have record 2, but in your table 2, you don't have record 2. So it won't match. So it won't return this record at all. So your inner join is very, very important, in such a way that if you want to extract the only common records, for example, whatever the records that are there in this table, I need only those records from the other table also. In that case, your inner join will help. Okay, so now let us see. Simply I will insert a record into my table underscore test. Okay, so I'm inserting the sixth record, and the sixth record name is Tommy. Okay, but when you do the inner join, you don't get your sixth record, because your sixth record is not there in your second table. Okay, so understand the functionality of inner join, guys. Your inner join will be utilized when you want to extract the most common records between the tables. Okay, if it is not matching, then it won't return. So the on condition, we need to understand, guys, the on condition. Okay, t1 dot id equals to t2 dot id, then only it will return. If it match the condition, then only it will return. Okay. Here the sixth record in T1 is not matching with any record in the second table. So that is why it is not returning you anything. Okay. So your inner join is something that you need to utilize when you want to extract the common records between the tables. Okay. Any questions, guys?
No.
Hope
Mr.
everybody is.
Vikram, I
Yeah.
had a doubt.
Yes.
Suppose we have created two tables, right?
Yes.
In that ID should be common in the both the tables. If
Mhm.
the ID should be different, data type should be different. Does the query execute?
If the ID is different,
That means ID data type should be different. Does the query execute?
it won't.
Oh,
So both the IDs should be of same data type. It won't execute. Both the IDs, for example, if you want to match a string data type with the integer data type, it is not possible. Okay, you need to play a casting in the condition. You need to apply a casting in the condition. You need to convert any of the ID to integer like this. For example, in your first table, you have an integer column, and in your second table, you have a string column, and you are trying to apply a join condition on the both columns. Then you need to apply casting in the condition.
yeah, okay. Thank you.
Any other questions? Okay, so let's move on to the next join, which is actually the left join. So we have seen the inner join, and we understood how actually the inner join will work. Okay, and we know the purpose of inner join, and now we will try to see what is actually the left join. Okay, so in your left join, if you try to see in your left join, in your first table, okay, right now at this moment in our first table, if you see, we have 6 records. Okay, 1 2 3 4 5 6. In our second table, we have 5 records. We have 5 records. So now, though, even though it is not a common, I want to extract the data from both the tables. So in that case, you can go for left outer join or left join. So what this left join will do, it will give everything from the left table that you specify, meaning in our case it is T1, and it will give the matched records from the right table. The unmatched records from the right table will be null values. Okay, so let us try to experience this left join. See here, from 1 to 5, you got a match in the second table, so it has given the records. But for sixth record, it doesn't find any match, so that's why it has given null values. Okay, so now if you see, it has given the entire left table. How many records are there in that left table doesn't matter. When you are using a left join, it will give everything from the left table. Everything. It will give all the records from the left table. And then it will give only the matched records from the right table. The unmatched records will be the null values. This is the functionality of your left join. Okay, So before going to the next join, I just want you to ask one more question. Okay, one question in your in our inner join. So let us take an example. I have six records here in my table test. Okay, and I have five records in my test stage table. Okay, now I'm inserting one more record into the stage table. Okay, I'll try to insert few more records. Okay, so let us see our first table now. See here, I have these IDs. Okay, so one Scott, two Blake, three Clark, four James, five Joseph, six Tommy, and again I have got one record with different name, two record with different name, and one record with a different name. Okay, now in the second table, in the second table, I have one record with age 25. Let me place side by side so that. Okay, so here if you see, this is our table, right? I have, this is the first table and this is the second table. So anybody, can explain how actually inner join behaves in this case? How many records I will get?
8 records.
Eight records. Why eight?
So matching the records in the left join, left column. Here we having one,
Uh-huh.
two, three, four,
Are
five.
you sure?
Yes,
Eight records. The inner join output is eight records, you are saying.
yeah. Which matching the record.
Okay. So how it will match? I mean, just now we have discussed inner join won't take the non-matched records, but we don't have six here, right? How it will take
Yeah, it
the
won't
sixth?
have six, but repeated one, two IDs.
Okay. So
Returns
repeat.
returns only rows which match in both tables.
Okay. So in that case, your inner join should return how many records?
Seven, I
Five.
Come on, guys.
Yeah, Venkat,
Mm.
can you go to that desk?
Yes.
Yeah, here from the first table we have
Mhm.
one, right?
Yes.
One will uh, check for every occurrence in the second table also. We have two times, right? Repeated.
Yes.
It will
Yes.
check for
Yes.
every record in the second table and
Yes.
get the count.
Yes. So now you have ID 1 repeated twice in the first table and the same ID 1 repeated twice in the second table. So it is a multiplication, guys. Two records are matching with the two records. So 2 into 2, how many records you will get? 4. For only ID, you will get 4 records. ID 1, you will get 4 records. For ID 2, if you see, you have 2 times repeated in here and you have 2 times repeated here. For ID2 itself, you will get 4 records. Guys, are you with me? Your ID2 record is matching 2 times here. And again, your ID2 came. It will match again 2 times. Right? So for ID1 and ID2 itself, you got 8 records. Are you with me, guys?
Yes, yes.
Okay, so it is not 8. I think it is not even 11 also. Let's see. Yeah, I
Yeah, I think we need to count.
yeah. So let's apply the inner join and see. So we need to understand the functionality, guys. This is the most important interview question we will face in real time. Okay. So majority of the people will answer inner join will return common records, but then immediately interviewer will give this kind of questions. Okay. So let me write this: select star from table underscore test t1 inner join table underscore test underscore stage t2 inner join, sorry, on t1 dot id equals to t2 dot id. Okay, so when you do this, I think it's 11 only. Oh no, just see. You will get these many records. Do we have these many IDs? Okay. See this. Understand the output, guys. Let me put the tables in a different screen. So you need to understand, you need to test these cases and you need to understand. How to paste it in side by side screens. Okay, let me take another query tab. Okay, so here if you see, I have this inner join table test. Let's see this how it will take. See, it matched 2 2 2 2. Okay, so second record came 2 times. Why first came 3 times? Anybody have any idea, guys? 2 2 2 2. But one record came 3 times here and then 3 times, 6 times. It should occur only 4 times. I mean, we have 3 records of 1, is it? One, two. Oh, we have, sorry, we have 3 records. Yeah,
Yes,
correct.
we updated 3 records.
Yeah, so here if you see, we have 3 ones here. Okay, and if you see the output, the 3 ones got repeated once and then second time. Okay, so 3 into, so how many times we have here? In the second table, how many ones we have? So in the first table, we have 3 ones. So we have 2, 3 into 2. So 6 times it will repeat, right? See here, 6 times. Guys, are you with me, guys? Are you following what we're
Yeah,
trying to understand?
yeah, we got.
So how many times it will repeat? So those many times it will match. Okay. So the condition you need to check the condition. Yes, it will return the common records. When it will return the common records, it will return the common records if you have the unique values in your both columns. Okay. But if you have duplicated values, in your both columns, then what it will do, it will match all the duplicated values. Okay, it will match all the duplicated values. So that is the importance of your join. Okay, so you need to understand its behavior. Otherwise, in real time, what will happen when you are joining very big tables which are having duplicate records, it will go for exponential record count, right? So in that case, it will be very difficult to analyze your cost of the query and analyze the compute that it is taking. Sometimes it will lead to escalations also, right? So this is very important, guys. In real time, when you are joining tables, you need to check the mapping key, proper mapping key. Okay, if you are not checking the proper mapping key, and you unknowingly, if you apply a join between two columns which are duplicate columns, then it will be waste of all the time and compute. Okay, so right now here we are seeing 4 to 5 records, but in real time you will see millions, billions of records. Okay, so we will be seeing the tables of size around 1 terabyte, 2 terabyte, 3 terabyte, right? I have seen 10 terabyte table in my entire career. So once I have seen 10 terabyte table, right? So this much size of tables, if you see, and if you try to apply this kind of joins with the fun, right? So then you are gone. So your query will run for days, and it will eat all the compute, and then it will add huge cost to your project. So then admins will found you, and they will send emails to you. Hey, what have you done? Why you have run this query? Because of this query, the entire database went down. Right? So you need to understand the criticalities of it also. So the reason why I'm explaining it is, you need to go and check before applying the join. You need to go and check what are the distinct values in it, right? What are the unique values in that column? And then, is it a primary key column or not? Or is it a unique column or not? Okay, so then only you try to apply the join. Otherwise, what will happen? It will try to hit multiplications of your records. Okay. Any questions, guys? Any questions?
No.
No.
Okay. Okay. Fine. That's all I have for today, guys. Tomorrow we will see the remaining joins, and then we will see the advanced analytics functions tomorrow. Okay, and then we will wind up the SQL sessions. Okay, so that's all I have for today. Thank you so much for joining once again tomorrow.
Thank
Thank
you.
you, sir.